We are now in Module 19. We are finally on the last way to solve a quadratic equation. If you guys remember, we've been talking about equations. They have equal signs, and quadratics have x squareds, which means how many solutions? 2. We've been discussing that there are many ways to solve a quadratic. We talked about factoring and the fact that factoring doesn't always work. We talked about the square root method, and again we saw that it doesn't always work. So on Module 18 we learned how to complete the square. And although completing the square will always solve a quadratic equation, I do not prefer that method because it's long. It has 6 parts or 6 steps, and those are hard to remember. So today is our last method in Module 19. And today we're going to solve a quadratic equation using a formula. And this way I prefer better. So let's go to our notes. If you look, there is a formula up there. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. That formula is called the quadratic formula. You can only use that formula to solve a quadratic equation. If you look in that formula, there's a plus and a minus, which means you're going to get 2 answers. Now, the first part about using the formula is it's got to be memorized. So, we're going to sing it. And if you know the tune, Pop Goes the Weasel, it goes to that tune. So, I'm not the best singer in the world, but I'm going to give it a shot. So, to memorize the quadratic formula, you sing x equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's try again. Sing it with me. X equals negative b plus or minus square root b squared minus 4ac all over 2a. I guarantee if you sing that enough times, you'll have it memorized. Now, formulas are great. All you do with formulas is plug and chug. You replace the variables with numbers, and then you work the numbers. So you all have been working formulas since elementary and middle school. We've been working formulas in this course. We did the Pythagorean theorem the other day. So now what we're going to do is learn where do the numbers come from that we're going to substitute in, and then how do we work it step by step, reviewing our rules. So we're going to go to example 1. Example 1 is the quadratic equation x squared plus 5x minus 6. Let's go to the board and look at that. So pretend I want you to solve this, and you forgot how to factor, which sometimes happens. Sometimes you look and you forget about factoring. We could solve every quadratic equation using the formula. So over here to the side, we're going to write the formula. So it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. And the all over is important. All of that is in the numerator and the 2a's in the denominator. So if you don't write the fraction bar going all the way across, you're wrong. It goes all the way across. Now, to use this formula, you need a number for A, a number for B, and a number for C. Those numbers come out of the equation. All quadratic equations have to be in what order? That's right, descending. And if you look at every quadratic in descending order, you see 3 numbers. What is the coefficient in front of x squared? It's 1. That is always your A. So your A is always the coefficient in front of x squared. What is the coefficient in front of x? It's 5. That's your B. What is your constant, your number that stands alone? That's negative 6. That's your C. So the first thing I would write down are my 3 numbers. A is 1. It's always in front of x squared. B is 5. It's always in front of x. C is your constant. That's your negative 6. Now what we're going to do is we're going to take these numbers and plug them in as we go. The less we write, the better. There are technically 4 parts to this formula. The first thing is you must write x equals. If you do not write x equals, then I don't know. It's an equation, and I don't know what you're solving for. Here's where we start the filling in on the right side. Right here is the first part of the formula. Negative b. A negative is what operation in math? It's subtraction. And subtract means whatever goes behind it changes, becomes the opposite. So in this spot, you're going to put the opposite of b. And if you remember your vocabulary, the correct word for opposite is additive inverse. So look here. What's your b? 5. I want the opposite in that spot. So the opposite of 5 is negative 5. Then I'm going to write plus or minus square root. The next part of the formula is right here, b squared. Well, we've been squaring for a while. Squaring means to multiply the number to itself. You guys can do that in your head. So everybody look, what's your b? 5. Square it in your head. What is 5 squared? 25. You should all know when you square a number, it's always going to be positive. So the first number in the root symbol should be positive. Now, the third part of the formula is all 3 of this. Negative 4ac, because that number and those 2 variables are connected by multiplication. So you're going to take negative 4, you're going to multiply it to the number for a, and then take that and multiply it to c. So this is what I do. I do negative 4 times a. Negative 4 times 1 is negative 4. Then I go multiply it to c. Well, a negative 4 times a negative 6 would be a positive 24. So do not assume that because you see a negative here, this symbol's always going to be negative. You're multiplying 3 numbers, and you can multiply 3 numbers and make a positive. So pay attention. A times c, 1 times negative 6 is negative 6, and then multiply it to negative 4, you get positive 24. Then you write all over, and the last part of the formula is simple. 2 times whatever a is. So we're going to multiply again. So we got a 2 times 1 is 2. Now, once you get here, you are not doing algebra. You're doing arithmetic. It just so happens when you do this arithmetic, you're using everything we've learned in this course. You are using fractions, you are using square roots, you're using like terms, order of operations. So let's talk about this. If we follow, please excuse my dear Aunt Sally. We're supposed to do parentheses first, but P doesn't just mean parentheses, it means anything in a symbol. So here's where we're going to work first, the root. So we copy x equals negative 5 plus or minus square root 25 plus 24 is 49 over 2. So we combine what's in the square root. We're not done. P means do what's inside. We're going to do what's inside now. We're going to square root it. So we're going to copy. And this is the problem. You've got to write stuff down. This is x equals negative 5 plus or minus. What is the square root of 49? Well, 49 is a perfect square. So that's a 7 over 2. But we're not done now. We still have add and subtract, and we have divide. But wait a minute. We can't add and subtract at the same time. So this has got to be broken up into 2 parts. You're saying x equals negative 5 plus 7 over 2. X equals negative 5 minus 7 over 2. That plus and minus belongs to the 7. 1 7 becomes positive. 1 7 becomes negative. The other numbers stay the same. Okay, guys, now we're doing arithmetic. Negative 5 plus 7 is 2, and 2 divided by 2 is 1. So the first solution we could write is x equals 1. The other solution, negative 5 minus 7 is negative 12, and negative 12 divided by 2 is negative 6. So we do get two solutions. We get a positive 1 and a negative 6. So all it is step-by-step procedure of arithmetic. But the first thing is you got to be able to get the three numbers from the equation, substitute them incorrectly, and then follow your process. Inside the square root should be one number, then you square root that number. Then you write two equations and you solve each. Now it's important, we got some vocabulary here. There are two answers here. We're going to use our correct words to describe these answers. So if I said describe your solution, you would say you have two answers. Are these answers on the number line? Sure they are. What do you call the numbers on the number line? Real. If you also remember, on the number line, numbers can either be rational or irrational. Well, that takes us back to many modules ago. The word rational has the word ratio in it, and a ratio means a fraction. So if these are rational numbers, they can be changed to fractions. How do you change 1 to a fraction? You write 1 over 1. How do you write negative 6 as a fraction? Negative 6 over 1. So these are rational numbers. So we would say we have two solutions that are real and rational. Now, I would have known that from the very beginning. There is a little trick built into this work that will help you decide whether your numbers are going to be rational or irrational. And if you look right here, this is the key to the quadratic formula. When you get one number underneath the square root, this number has a special name. It is called the discriminant. Now that's a big new word, so I'm going to write that down. Discriminant. The discriminant is the number when you get one number underneath the square root. The discriminant is 49. Think about that. What have we already talked about this semester about 49? 49 is a perfect square. So, guys, if the one number underneath the square root, the discriminant, is a perfect square, you are guaranteed to have two answers that are real numbers and rational. And that's important. So when you're doing your work for the formula, check out this number underneath the square root. Okay? Now, just to reiterate something that we've done a couple of modules ago. This was not the quickest way to solve this quadratic, but using the formula will always work. So if you want one method to solve every quadratic equation that will always work, the formula will. If I was teaching you in a higher math class, I wouldn't solve this one by the quadratic formula. Because if I go back up here to the beginning, this quadratic is set equal to 0. Well, the first way I told you to solve quadratics is by factoring. And if you look, if we factor it, we're going to get the same result. Because x squared is x times x. What can multiply to 6? 1 and 6, 2 and 3. I want to subtract to make a 5. It's got to be the 1 and 6. 2 and 3 would not subtract to make a 5. If I want to subtract to a positive 5, the 6 is positive, the 1 is negative. We've already discussed this way back when in Module 16. If you factor a quadratic, you make two linear equations, and then you solve each. And there's x is 1, and there is x is negative 6. Isn't that the same two solutions we got here by doing the formula? Sure it is. So here's the problem if you're moving on to a higher math class, say college algebra. When you get to that higher math class and they say solve a quadratic, they want you to think, what's the quickest method you can use to solve it? If this was the quadratic I gave you in a higher math class, I wouldn't do this one using the formula. I would do factoring because it's quick and easy. The formula works, but it's not the quickest way. So it's very important you don't forget what I've taught you already in this modules. There are 4 ways to solve a quadratic equation. You want to find the way that fits best. All right, let's look at one more of your quadratics in your notes. Let's go to equation 3. Because again, you have to understand the process. Okay? So equation 3 has x squared equals 8x plus 11. And it says to solve. It's an equation that has an equal sign. It's quadratic. It has an x squared. Now look, the first thing that should probably pop in your head is say, ooh, the square is on the left. So I should do the opposite and square root it. Well, that's a great idea. And I agree. Squares and square roots would cancel out and leave x equals. But again, if you do the square root method, you want a number on the right. Can you square root 8x plus 11? No, there's a variable there. That's why the square root method doesn't work. So that's out. All right? Well, I've already taught you, you could also factor. But a factor, you want the equation set equal to what? 0. Now here's my question. Do you move the x squared to the right, or do you move the 8x plus 11 to the left? We've already discussed this. You never want to make your x squared negative. So we're going to leave the x squared. We're going to move the 8x by subtracting it, and we're going to move the 11 by subtracting it. And we can move them both at the same time because we're moving them by the same operation. So on the left side, you have x squared minus 8x minus 11 equals, these are going to cancel these terms and leave you with 0. So now that it's set equal to 0, I'm thinking, hey, let's just factor it. It's a trinomial. I'll put 2 parentheses. I get x and x. What can multiply to 11? 1 and 11. Can 1 and 11 subtract to 8? No. 1 and 11 subtract to 10. So there's our second problem. It doesn't factor. So because square rooting was out and factoring was out, now you have an option. You could do the method in Module 18 called Complete the Square, or you could do today's method, the quadratic formula. Personally, I like the quadratic formula better. So that would be where I would go. I would say, okay, I'm going to do the formula. So I need 3 numbers. I need A, B, and C. Where do I get them from? Looking at my equation in descending order. A is always in front of who? X squared. A is 1. B is always in front of who? X. B is negative 8. C is always in the constant. Who's the constant? Negative 11. Once you get those 3 numbers, now we're going to work the formula. So we're going to sing x equals negative b. That means put the opposite of your b. Here's your b, negative 8. So the opposite would obviously be positive 8. Think about it, guys. Do I really want to see you write negative and then put there a negative 8? 2 negatives are going to make a positive. Then you write plus or minus square root. Now we're going to do b squared. So take your b and square it in your head. Negative 8 times negative 8 is positive 64. And this first number will always be positive, because when you square, you get a positive. Now, this is minus 4ac. So you want to multiply a and c together and then multiply it to negative 4. Or you want to do negative 4 times a and then multiply it to c. It doesn't matter how you multiply it, as long as you multiply those 3 things. So I'm going to take a and c. 1 times negative 11 is negative 11. But then I'm going to multiply it to a negative 4. And a negative 11 times a negative 4 is a positive 44. All over 2 times a. 2 times 1 is 2. Once you get the numbers in, all this is arithmetic. Follow the rules of please excuse my dear Aunt Sally. So you do what's in the symbol first. X equals 8 plus or minus square root 64 plus 44 is 108 over 2. We've already discussed this over and over again. Any number in a square root has to be reduced. We got a problem though. Is 108 a perfect square? No. So now we got to go up here and we got to reduce it. So here we go back to basics. Chapter 15. what is the biggest perfect square that will divide into 108? If you use 4, you're wrong. I know 4 divides into that, and 4 is a perfect square, but it's not the biggest. The biggest perfect square in 108 is 36, and that would be 36 times 3. So the square root of 36 is 6. It comes out. Can you ever square root 3? No, it stays inside. So now this is going to get replaced for that radical. So now we have x equals 8 plus or minus 6 square root of 3 over 2. You with me so far? So just like you learned, if you have a root, it has to be reduced, broken down. Because that's not a perfect square, we had to do our work. Now, this is plus and minus means there's 2 solutions. So this is really x equals 8 plus 6 square roots of 3 over 2. X equals 8 minus 6 square roots of 3 over 2. Because it's a fraction, we're supposed to combine the numerators first. Here we go again. You've learned a lot of information in these modules. That's a whole number 8, and that's a 6 square roots of 3. Can you add that? No way. They're not alike. That is a whole number, and that is a root. They're not alike. You cannot add them. So you have to leave the numerator. But wait, it says to divide by 2. Who are you dividing by 2? Well, look at the bar. It's going straight across, so it means to divide both. So I could break this up and write 8 over 2 plus 6 square roots of 3 over 2. And now we can divide. 8 divided by 2 is 4. And because 6 square roots of 3 is connected by multiplication, we sure can. 6 divided by 2 is 3 with a square root of 3. Can we add that? No way. A whole number and a root are not alike. That's as far as we can go. Now, I've showed you this once before. I'm going to show it to you again. Because this divide by 2 goes straight across, you can look here and do it all in one step. Instead of breaking it into 2 separate parts, you could say, okay, circle all the whole numbers. What you look like when you circle all the whole numbers is I call this Mickey Mouse ears. It looks like the Mickey Mouse ears. The rule is either all these whole numbers divide by the same thing or you leave them. Can you divide 8, 6, and 2 by the same number? Sure, you can divide it by 2. So 8 divided by 2 is 4. Bring down the minus. 6 divided by 2 is 3. Leave the square root. And 2 divided by 2 is 1. Do you need to leave a denominator of 1? Of course you don't. There is your solution. Now, look at those answers for x. They're not very pretty. They're ugly. I would have known that I wouldn't have got nice rational numbers if I went and looked at my discriminant. So to recap, the discriminant is when you get the square root to be one number. So if I look at my work, my discriminant is 108. And if I ask you to tell me the discriminant, that's what you'd write. The discriminant is 108. Because 108 is not a perfect square, that guarantees me that my answers wouldn't be rational. They would be the opposite, which is irrational. So if I asked you to explain to me, describe these answers, describe these solutions, you would say I have 2 answers. They're real. They're on the number line. Now I know what you're thinking. You're saying, no, they're not. If you type that in the calculator, you get a decimal. If you type that in the calculator, you get a decimal. But those decimals are not rational. They're like the famous decimal pi. They are irrational. They go on forever and ever with no end. So it's very important when you're working the quadratic formula. Not only do you get 2 answers, but you double check yourself. If under the root is a perfect square, your answers would have been rational. Nice. They would have been fractions or whole numbers. If your number underneath the square root, your discriminant is not a perfect square, then your answers are always going to be irrational. And irrational means they're going to have a square root symbol in them, which means they would be decimals. And that concludes all the 4 methods to solve a quadratic equation. I know that's a lot of information, But you really have to have this mastered to go on to college algebra. Because in college algebra, all the equations we solve get turned back into being quadratic. And you have to know the different methods, because not all the methods always work. Okay, see you the next module.